This is a pretty easy math problem, but I'm going to go over it because it is the basics of electric fields. We've got a couple of charges here, this plus, and this minus. And they're all going to have some sort of influence against this x right here. So you got to try to figure out that. And now keeping in mind, it's not a force, it's the electric field. So it's going to be K times Q over R squared, and this newtons over coulombs. So let's try to figure out the directions. Now, when it's plus, it's always going to be pointing outwards from the plus. So away from the plus, this direction. And that's a 7, so it's going to be kind of small, but hey, we'll go with that. And then over here, this is a 20, but it's actually kind of further away. So it might be somewhere about the same. You never know. But this one here is going to be plus as well, so it's going to be pointing away. It's going to be something like that, right? And then we have the minus over here, so I'm going to throw that one in there. And this one is always pointing in towards the minus. We're going to go this direction. It's really close too, so it's pretty strong. Just like that. All right. And now what we can do is we can try to add these up. So let's see. We're going to break these all into components first. So we'll try to label this one as A, this one as B, and then this one as C over here. All right. And then what we can do is say for A, EA is going to be, all right, well, we have nothing in the x direction. So let's just say 0i in the x direction. But then we would have minus in the negative direction, whatever we get here for K. So we'll put K, and then the Q is going to be 7 nanocoulombs. Or, well, actually, it would be more like 7e to the negative 9 coulombs divided by this r squared, which is going to be 0.04 meters squared. And then we would have the next one, I suppose we can do. It's pretty easy to go to B over here. So we'll go with B. EB. That's going to be a whole bunch in the x direction. We'll go K times whatever we get there is going to be 10 and, or actually E, 9 C over, and then we would have 0.03 here, meters squared. And then we would say this is I. Let's make sure that this one is J. And then we're going to basically 0 in the J over here. And we could say, okay, for C, this is going to be EC. All right, now it might be a little bit harder because we have to figure out what this angle is here, right? But it shouldn't be too bad. Well, okay, let's say this one was 3. And then we know this one to be 5, right? And so what is the cosine? Cosine is going to be the adjacent of our hypotenuse. So 3 divided by 5. All right? And so that's what the cosine is. And so we can just basically say that this is going to be negative I first, negative K, and then you put the Q in there, so it's 20 e to the negative 9 coulombs divided by 0.0. This would be 5 meters because it's this far away, right? All right, and so that's 5. And then over here, this is I. But here's the problem. Remember that we need to do the cosine theta over here, and the cosine theta is 3 over 5, right? So we do 3 over 5 right here, and then what we can figure out is maybe this direction, which was the J direction. Running out of room a little bit over here, but this would be I, and then we would also have a negative J, so negative K, same thing over here, 0.05 meters squared, so it's not too big of a deal, it's the same thing, but what are we going to multiply over here on this side? It's not going to be 3 over 5, because that's the cosine, but I don't still really want to do too much more stuff, so I'm going to go over here. I'm going to use this one that I kind of know is 4 centimeters, because I know that the sine of theta is supposed to be that one, so it's 4 over 5. All right, so that's what I can use over here, it's just 4 over 5. All right, so let's try to rewrite this one more time. So we have EC is equal to negative K 20 e to the negative 9C 0.05 meters squared, 3 divided by 5I, minus K 20 e to the negative 9C 0.05, and then this is 4 divided by 5. Okay, and that's for EC. But we're going to add all this stuff together. So let's just start with that, and we'll go ahead and add this to it, right? So you can sort of go, we'll just kind of even add those things together all at once. So we'll go E, A plus B right here. Is essentially going to be K 10 e to the negative 9 coulombs divided by 0.03 meters squared I, and then minus K times 7 e to the 9 coulombs 0.04 meters squared J. And so we kind of just condense both of these two things into that. And now we can just kind of add these two together. And, well, let's try doing these two. So we add those I's together. I could say E, this is basically net E is going to be equal to, I mean, we can go with this one minus that one, right? So, and I'm going to put this in parentheses like this. So 10 e to the negative 9c divided by 0.03 meters squared. And then we're just going to subtract 20 e to the negative 9c divided by 0.05 meters squared. And then we can multiply that by 3 over 5. Make sure to do that. This 3 on top, 5 on the bottom, and that's going to be what we get for I. All right, this is the x direction. And then if we did the same thing for EY, we could get we would get K times these two things are going to add together, so it's all going to be negative K here. Negative K. Negative K, and then we'll just you just add those two together, so 20e negative 9, and I'm just sort of like 4 divided by 5, there's going to be 0.05 meters squared times 5 on the bottom, and then plus 7e to the negative 9c. Okay, so that's for the J direction. So if we were to work this out, let's just go ahead and do the parentheses first. So we'll go 10 e to the negative 9, and then we'll put that on the little thing there. We're going to square that, minus another one of these, 20 e to the negative 9. Then multiply the top by 3, and the bottom 0.05 squared times 5. All right, and then that's going to be this. I'm going to multiply that by K, so times 9 e to 9. And I get this number right here. So that's going to be the x component here. Net EX is going to be 5, 6, 800. This is in the I direction. And let's not forget the units as well. It's going to be N over C. Awesome. And then for the Y component, it would be over here. So you can just kind of do that again. So start with the 20, negative 9, and then times 4 on top. Divide that by 0.05 squared times 5 on the bottom. Go ahead and add that to the 7e to the negative 9. Divide that by 0.04 squared. Okay. And we get this number, we can multiply that by 90 to the 9, and we get that number, and it's negative, of course. So minus 96,975. All right, and of course, once you put those two together, 56,800, and over C, I, minus 96,975, J. You can do the squaring this, so 5,6,800 squared plus 96,975 squared. And then you could square root that, and you'd get this, you know, the magnitude here. The magnitude of E, you know, would be 112,385 or so. If we were to try to find the angle here, then we're going to try to figure out which direction this is pointing. And keep in mind that the components at the end, we're going to be a little bit positive this way and somewhat negative that direction. So it's going to be pointing somewhat like that. And we want this angle right here. So let's try to set this up more like that divided by that, right? The arctangent of 96,975 divided by 56,800 will give you divided by 56,800, and that's just going to be 59.6 degrees. So that's going to be that's going to be the direction of this right here. This is negative. I'm going to put that right here, negative 59.6 degrees. Awesome. So, yeah, this is a little bit difficult, but at the same time, the math isn't too bad. It's just kind of conceptualizing and angling all these things out. You got to kind of know the trigonometry.